Hello everyone. Today we are going to discuss a time series forecasting problem, and the project name is Demand of Products at a Retail Outlet Based on Historical Data. This is a problem which I got from the TCS Eon internship. So for this is typically a time series forecasting problem, and the main agenda of this is to forecast the sales value of a store for the year 2018 provided with the trend data from the year 2013 to 2017. So we are given a test and train CSV files. For doing the problem, first of all, we have to import the dependencies. And the models that we are going to build are IRIMA, SEDIMAX and FB Profit. So I have imported all the dependent files here, dependent libraries over here, and next is data collection and data analysis part. First of all, we have to load the train and test data into two data frames and do some basic analysis like plotting the train head and tail part. So basic analysis gives us an understanding of when is the data's date is starting. For example, the train data is starting from 1st January 2013 to the last day of December 2017. So that means it is a 5-year data that is given as train. For the testing, we are received the data from 2018 1st Jan 2018 to 31st of March 2018. That means first 3 months of 2018, that sales value we are going to focus in this problem. After that, we are going to do a data pre-processing. It basically involves identifying what are the data types, then what is the statistical values, everything. So we understood that the date is an object type which is obviously needed to convert into date time. Then the basic data pre-processing steps, just a basic plot is also drawn. So I'll be discussing this problem in a quite faster manner because this is a very big problem with a lot and lots of steps involved. So that's why it's going a bit faster. And next is identifying the statistics of each store. So I have used a group by function to find out the statistics of each store. So if you need to write this code down, just pause the video and take a screenshot of this, because yeah, takes a lot of time to explain line by line. Then another group by function to find out the unique items in the store. And from the basic analysis, we understand that we have 10 stores and each store sells 50 items. So to make this problem more interesting, I am going to forecast the sales of each store 1 to 10. The forecasting is going to be done for the year 2018. That's the agenda I have set from the problem. So these are the basic data pre-processing steps, and after that pre-processing, we are going to the data visualization to understand how the sales of each store, how is the sales of each item is happening, which store is having the highest sales. So the basic visualization to understand more on the data is being given here. So here we can see the total sales per store as given. So from this, store 2 is having the highest sales, and then next is total sales per item. So we have plotted the item ID. So the item ID, you can see the item ID 15 and 28 is having the highest sum of sales. So likewise, some more visualization is also done. You can check on here what are the criteria I have taken for visualization. So this is just to identify how the sales is happening for each store. So just scrolling down, these are just visualization parts. Since there are a lot here, we can see a lot of plots because I have taken for every store, because there are 10 stores. So I have taken everything for every store. So total sales for store ID 1, total sales for store ID 2, like that. For every store I have done a visualization for a better understanding of the data. And next is create the total daily, monthly and annual data frames. So that is also optional. If you want, you can do. I have created it just to see the daily sales. This is a daily sales, this is a mean daily sales, monthly sales, mean monthly sales, yearly sales and mean yearly sales are also calculated. Next is a resampling of the sales value. So I have done the resampling of month wise resampling for every store, year wise resampling for every store and the quarterly resampling for every store, and it is plotted in a graph using this plt dot subplot method. See, you can see the month-wise resampling of every store from store 1 to 10. So there means we can see there is an upward trend of sales for every month is happening, and also the yearly resampling will give you a plot like this shows an upward trend is there in every year. The sales is going up every year. That's the inference that we are getting from this visualization. And this is a quarterly, so almost similar kind of graph we received in the quarterly as well. And okay, this is so these are just optional visualization steps I have done to further identify the data. You can skip this part because this is a visualization for every item. Since there are 50 items in every store, this is going to be a very huge plot. I have written this code in for loop, so in a single line of code we can make a huge amount of plots like this. And skipping those parts, next is coming to the decomposition of the analysis of monthly trend and seasonality. So the monthly trend and seasonality, this is how the trend is going upward, and the seasonality is like you can see every 1 year, after every 1 year there is some seasonality. That's how we got from the graph. Next is ETS, error trend seasonality decomposition in this time series analysis. So while decomposing the entire sales value from 2013 to 2017, we see that the trend is going upward. There is some kind of seasonality graph is like this, almost see it's kind of non-stationary. It looks like a non-stationary graph, and some kind of outlier values are also there, that are the residues visible here. And this is for all the stores also I have done this decomposition. So this is a graph for store 1 to store 10, the decomposition done separately for all stores as well as the entire data set. Next, since from the graph it is clear that the data looks almost stationary, we need to do a augmented Dickey-Fuller test to check the stationarity of the data. So in this augmented test I have done this for store 1 to 10. So this is the code for store 1 to 10, and then it's a function, and this function is called for every store. So the output we are getting is that the store 1 looks it's stationary, and from the store 2 also this is looking stationary. So the graph of every store is looking stationary. So we assume that the data is stationary even though it follows an upward trend, because this augmented Dickey-Fuller test gives the output as the data is stationary for every month for every stores. Okay, now keeping this in mind, we are going to make the model. First one is the ARIMA model. Okay, then coming to the ARIMA model building. So these are some basic analysis plots I have done. So for building up the ARIMA model, first of all we need to find out the autocorrelation and partial autocorrelation. So this is the code for plotting the autocorrelation, PCF and PACF, ACF and PACF plots. So from this it's clear that see the first point is repeating after 12 months. That means in every 12 months there is some correlation happening. So that means from these two graphs we identified that the look back period is 12 months for every store. So all the store is following almost similar graphs. So every store the look back period is taken as 12 months. So keeping this into information into account, we are going to split the train and test data. So the train and test data, the train data is splitted as first 43 column wise, and then 43 and rest of the column wise, 48 and rest of the column wise. So this is how we are splitting the train and test data, and then going to build the ARIMA model for store 1 to 10. So first of all we are running an auto ARIMA to find out the PDQ order. So we got this PDQ order and the seasonality as 12. That means there is a seasonality occurring after 12 months. That's what we got from this autocorrelation graph. And then after finding out this, now next is see, this is for store 1 to 10. Since you're seeing the repeated code, because I have return for loop for store 1 to 10 all the time, because this is a forecast model to predict the sales value for store 1 to 10. So after finding the PDQ value, we apply it and built a Sarimax model. Say, since the ARIMA model is converted to Sarimax at this point, because we find a seasonality component that is repeating after every 12 months. So it is better to go with Sarimax rather than ARIMA model to give a very accurate output, to get a very accurate output. Okay. Next, we have find out this residue, this quantiles correlogram of the Sarimax model for store 1 to 10. Everything is plotted, and then we going to predict the value of Sarimax model as well. So if in any point you need the code, you can just pause the video, take a screenshot and understand how it is written. So this is the code for Sarimax prediction for store 1 to 10. So here we are, the train and test data is printed like this, and the model is prediction. The variable prediction will have the predicted sales value. So, and it is again plotted for store 1 to 10. So you can clearly see that this is the sales value and this is the predicted sales value. So this is almost following a same trend and same kind of graph with a slight difference in the values. So the prediction is not bad at this point. From this graph it's very clear. It's almost a similar kind of graph we received. And next is we are going to make an evaluation. So for store 1 to 10, so evaluation is nothing but we are going to calculate the error, the root mean square error in this, the predicted value. So here we got the RMSE and MSE and RMSE like this. So the RMSE for the store 1 to 10 is falling in the range of 45 to 85. So this RMSE is not bad because this is low, and this forecasted value will be almost an accurate. The error in the forecasted value is very less. That's what we infer. We get the inference from this RMSE value, and then we are going to plot the forecasted sales value. See, look, for the 2017 till 2017 we know the sales value. For 2018 this is almost following the same trend but in an upward manner. So this forecasted value is almost following a similar trend. So this is how we received the forecasted sales value plot for the year 2018, and the sales value we obtained is forecasted sales value we obtained is we are just going to print the prediction value for every store. See, store 1 to store 10. See, the sales value for the first month is 1846 pounds something, and the 10th store is like this. So this is the output of the Sarimax model. Now coming, I'm so sorry I'm going so fast because this is a very huge project with a lot and lots of steps involved. So just to finish up everything, I'm going a bit faster. Next is FB profit modeling. For that, first of all, you have to install this FB profit and import the profit. Here the thing is that the date and sales column have to be changed into DS and Y. So that is a format that is required for this FB profit model. And also I have to add on one point to the ARIMA model, that is, since we have not seen that the data, haven't seen any stationarity in the data, and from the augmented test we got that the data is stationary, we skip the step of differencing the data. So we need not have to find out the differencing. That means in the order PDQ the D will be 0 in the ARIMA model. So I just skip the point over there. So I am just repeating that since the data is stationary, we didn't do the differencing. But in any other time series problems, if you find that the data is not stationary after the Dickey-Fuller test, then you have to do a differencing to make this data stationary. So if in one differentiation, if the data is still not stationary, you have to repeat the differentiation process until the data becomes stationary, and after that only we can make the ARIMA or Sarimax model. Since in this problem, in this particular problem, since the data is stationary, we skip the differencing method. Okay, then coming back to the FP profit model, we imported the file, the FP profit, and then we converted the date time column into Y and DS, that is a date and the sales column into Y and DS. That is very, very important. So because this is a particular format which is supported for the FP profit model. So our data frame should look like this. And then we did some analysis, and then we are going to fit the model into FB profit. that data frame into FB profit model, and then make future underscore data frame period is equal to 12. That means for every 1 year. That's how we are setting. And the model is built and the prediction values obtained here. Then we print the prediction value. So see, the plotted prediction value looks like this for the year 2018. Okay, and these are some components, store one dot plot underscore components of prediction. So we get the trend yearly, trend yearly. So this is how the trend of this prediction value is. And next is cross validation. So we can do a cross validation of this FB profit model. After that, this Y value will be the predicted sales value. So this is how we obtain the predicted sales value. And after performing the cross validation, I did print out the performance metrics. That means to check whether how much is the root mean square error in the predicted output value. So the RMSE value is calculated here, but you can see it's a bit larger compared to the RMSE of this Serimax model. This is in the range of about 150, 170 something. So the error rate is much more here compared to the other model. And this is a cross validation plot. And next is forecasted sales value for store one. So here you can see these are just for one store, because I have repeated the code for every store below, show you later. So then with the prediction value, just going to forecast the sales value for 2018. So this yard is the sales value for the year 2018. So this is how the sales value. And next is store to FB profit model. The same thing, we have going to make the prediction, then we did the plotting of the components, then did the cross validation, performance metrics plotting, and performance metrics printing. So all these things are done for every store 1 to sorry, store 10. The FB profit model is also built. Excuse me. And so here I am skipping the portion because the code is just repeated. Rather than writing the for loop, I just write the code separately for every stores, as you can see here. So this is the store 10 value. Okay. And now coming to the conclusion and the output. So we just did a comparison of RMSE for store 1 to 10 of FB profit model. So this is the RMSE scores. It's in the range of about 170 to some values are lower for some stores, but it's almost in the, see here we can see some value like 39, 67 for store 6. The store 6 values are RMSE scores are less, but comparatively the other stores are having a RMSE score greater than 100. So that's the inference we receive. So this is the RMSE graph for store 1 to 10, because here you can see the store 6. Here the RMSE, the error is very less for the store number 6. And the forecasted sales value for store 1 to 10 is also plotted. Store 1, the sales value is this one. For this every month of every year, we have plotted we have made a table for understanding the forecasted sales value as well. Finally, coming to the end of the project, we are going to compare the RMSE scores of Serimax and profit model. So Serimax is in the range of 45 to 85. That's how we received. But in the case of FB profit, the value range from 190 to 170, 100 range, above 100. So from this, it is evident that the best model chosen for 2018 value forecasting is Serimax model, since RMSE score is less compared to the FB profit model. So now we are finally printing the result value, that is the forecasted sales value of 2018 using Serimax model again. So these are the sales value. So for finally concluding the project, I have printed this output sales value into a sales.csv file, and all these files are stored inside, saved into this GitHub link. All the links for this project will be given in the description. So I hope you understood the basic overall idea of this time series forecasting model for forecasting the sales value for the year 2018 based on the previous year data. Since the project is a very big, I have to explain it in a very fast manner. If in case any doubt, comment below. Thank you so much.